So these are the topics that I just think are really likely to come up on the non-calculator paper. I've put together a selection of past paper questions. Let's have a go at them together and let me know if you've got any questions in the comments. We're going to start with surds. So a really common topic on the non-calculator paper, rationalise the denominator. Now to rationalise just means to get rid of the surd, which is the square root, from the bottom of a fraction. We can never leave a surd on the bottom of a fraction. And the only way to get rid of a surd is to multiply it by itself. Now if you times the bottom of a fraction, to keep that fraction equivalent, you also need to multiply the top. Root 11 times root 11 is root 121, which is just 11. So when you multiply a surd by itself, it just becomes the number. So we've got 11 on our denominator, and then for the numerator, we're doing 22 times root 11, and that's just 22 root 11. And now we've got a fraction, and we need to think, have we got anything in common? And yeah, we can divide the top by 11, and we can divide the bottom by 11, and that's going to be 2 root 11, and now it's rationalised. You might still be left with a fraction when you do that, and that's okay as long as there's no longer a surd on the bottom of a fraction. So that's that one done. That's just 2 root 11. Part B, show that root 3 over 2 root 3 minus 1 can be written in the form a add root 3 over b, where a and b are integers. So integers just means whole numbers. So they can be negative or positive, but they do need to be whole numbers. And again, we need to rationalise. You can see that we go from having surds and other stuff on the bottom of the fraction to just having a number on the bottom. So we are going to need to rationalise. Now this is a little bit trickier. Before we just had a surd on the bottom of a fraction, so we just times by root 11. Here we've got two terms. We've got a term that has a surd in it and a term that does not have a surd in it. Now to get rid of that surd, we need to multiply by something called the conjugate, which is going to be the same thing, but the opposite sign. So to get rid of this, we're going to multiply by 2 root 3, add 1. So this sign here, we've changed it from being a negative to a positive. And that makes something really cool happen, and that means that we'd cancel out and we get like the difference of two squares where those middle terms cancel. So I'm going to multiply everything on the numerator by that, and I'm going to multiply everything on the denominator by that. So you can put brackets around it if you find it helpful. Root 3 times 2 root 3 and root 3 times 1. So on the numerator, we've now got, now when you do root 3 times root 3, we know that this times this just makes 3. So you've got 3 times 2. So that first term just becomes 6. And then we've got root 3 times 1, which is just root 3. On the denominator, we're doing 2 root 3 times 2 root 3. Now, for this times this, we can do 2 times 2, which is 4, times, and then the root 3 times the root 3 gives us 3. So 2 root 3 times 2 root 3 is 4 times 3, which is just going to be 12. Then I'm doing 2 root 3 add 1, multiplying those together, and minus 1 times 2 root 3, and that's add 2 root 3 minus 2 root 3. So that's just going to cancel out. And then we've got minus 1 times minus 1, which is take away 1. So altogether, I'm left with 6 add root 3 over 12 take away 1, which is just 11. And now we've got it in that form that they asked us for, 6 add root 3 over 11, and that would be our final answer. Question 2, and I've picked another surds one here. This was from June 2019. 18a, express root 3 add root 12 in the form a root 3, where a is an integer. So the root 3 is fine. But the root 12, we need to think, has it got any square number factors? So 1, 4, 9, 16, 25, 36, 49. These are all square numbers. If ever a surd has one of these numbers as a factor, it can be simplified. So in this case, 4 is a factor of 12. So we can write this as root 4 root 3. You're always going to put the square number first, and then you're going to put whatever you need here to multiply with it to make root 12. So root 4, we've picked the 4 because it's a square number, and then 3 because 4 times 3 is 12. So that's that. And now, because we know the square root of 4 is 2, we can say that that is 2 lots of root 3. And this just needs to stay root 3. If you want, you can think of it as 1 root 3. And when you do 1 root 3, add 2 root 3, you get 3 lots of root 3. So that's our answer for that one. We've got it in the right format, so I'm happy with that, where a is an integer. For part B, we're going to express 1 over root 3 to the power of 7 in the form root b over c. Well, what does that mean? It means 1 over root 3 times 1 over root 3 times 1 over root 3, and we're multiplying it by itself. 1, 2, 3, 4, 5, 6, 7. Now we know that when we times fractions, we just do the top times the top and the bottom times the bottom. So all of those numerators are timesing together, which just makes 1. 1 times 1 times 1 times 1, 1 to the power of 7 is just 1. Now, root 3 times root 3, we know that root 3 times root 3 is 3, because root 3 times root 3 is root 9, and the square root of 9 is 3. So those two make 3, those two make 3, and those two make 3. So I've now got 3 times 3 times 3, which is 27, but we've got this root 3 left on its own, so I'm going to write 27 root 3. Now we can't leave it like this. We can never leave a surd on the bottom of a fraction. How do I get rid of that? I need to rationalise. So I need to times the top by root 3 and times the bottom by root 3. That leaves root 3 on the top, which is okay. We know there's going to be a surd left on the top of the fraction, over, now root 3 times root 3 just makes 3. So all I'm doing here to multiply these together is doing 27 times 3, which is 81. You can't simplify because the top is a surd and the bottom is a number, so we've got root 3 over 81 as our final answer. And that was 3 marks. So you need to make sure you know how to add fractions, subtract fractions, multiply fractions, and divide fractions. For adding and subtracting, you're going to make the denominators the same. For timesing, just top times top, bottom times bottom. That's the nicest one you can be asked. And for dividing, you're going to keep, change, flip. So here we've got multiplying, and we're going to make both of these mixed numbers top heavy to begin with. So to go from a mixed number to a top heavy, you want to do big times bottom, add on the top. So 3 times 2 is 6, add the 1 is 7 over 2. And again here, 1 times 5 is 5, add the 3 is 8 over 5. And we're multiplying these together. So we're going to do the numerator times the numerator and the denominator times the denominator. Don't need to make the denominators the same when you're timesing or dividing. 7 times 8 is 56, and 2 times 5 is 10. How many 10s go into 56? Well, that fits in 5 whole times, remainder 6 over 10. And then 6 over 10 can simplify and be 5 wholes and 3 fifths. Next one, we've got question 2a, work out 1 3/5, add 2 1/4. And again, I would encourage you to make both of these fractions top heavy. So 1 3/5, we're going to do big times bottom, add on the top. So 1 times 5 is 5, add the 3 is 8 fifths. Add 2 1/4, so you're going to do 2 times 4, which is 8, add the 1 is 9 over 4. And then we need to make the denominators the same. When you're adding or subtracting, you're making the denominators the same. So I'm going to make both of these out of 20. 20 is the first number that's in the 5 times table and the 4 times table. I've multiplied the first fraction by 4 to make it out of 20 on the denominator, so I also need to multiply the numerator by 4, and that's going to keep these fractions equivalent. So 32. For the second fraction, we've multiplied the bottom by 5, so we also need to multiply the top by 5 in order to keep that equivalent, and that is 45. So we've got 77 over 20. Now we need to give our answer as a mixed number. How many 20s go into 77? That fits in 3 whole times, because that's 60, with 17 left over out of 20. And that would be our final answer. Give your answer as a mixed number. Always check if the fraction part can be simplified. In this case it can't, so we're all good. That is fine for 2 marks. Part B of this question was 2 2/3 divided by 6 equals 4/9. And it's a show that question. So on a show that, you want to do the question and show that you get the same answer. So we're going to make this 2 2/3, we're going to make it top heavy. Big times bottom, add on the top. So again, this is 8/3. Divided by 6. Now we know that when we divide fractions, we keep, change, flip. So that first fraction is saying the same. We change the divide to a times, and we flip that 6 to be 1 over 6, and that is 8 over 18. That simplifies to be 4 over 9. and that's the same. So we've shown that we've got the same answer and we know we've got those 2 marks there. Question number 17, work out the value of 8 over 27 to the power of 4/3. Now this topic is index laws. I've also put a whole video up on my YouTube on this, so you can watch a whole video. I've made a booklet with lots of questions going through of this type if you find this difficult. So when we have the power that is a fraction, we're going to root by the bottom and do the power of the top. So that means in this case that we're doing the cube root first. So the cube root of 8 over 27 is saying something times something times something that makes 8, and something times something times something that makes 27. And we then need to do that to the power of 4. So that's going to be 2 over 3 to the power of 4, because 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. We then need to do that to the power of 4, so that's going to be 16, 2 times 2 times 2 times 2, over 81, which is 3 times 3 times 3 times 3, 16 over 81. And then we've got more index laws from a different paper, June 2018, this one was. 36 to the power of a half. The power of a half just means a square root. So x to the power of a half is the same as the square root of x. So if you are asked the power of a half, that is just the square root. So the square root of 36 is 6. 23 to the power of 0, anything to the power of 0 is 1. So that one's just 1. And for the bottom one, slightly trickier, we've got 3 things to do here. The minus power makes the base number its reciprocal. So 1 over 27, that gets rid of the negative. And then we need to do that to the power of 2/3, which is going to be cube rooting. Remember, we root by the bottom and do the power of the top. So the cube root would be 1 over 3, and we still need to square that, and that is 1 over 9. The cube root of 1 is 1, and the cube root of 27 is 3, because 3 times 3 times 3 is 27. Then that needs to be squared, which gives us the 1 over 9. Okay, next topic, algebraic fractions. So algebraic fractions is another really common topic on the non-calculator paper, and we're going to simplify this by factorising. You can't just cancel things out like this, that would be subtracting, okay? We need to divide the whole numerator and divide the whole denominator, and to do that we need common factors, and to do that we're going to factorise. So looking at the denominator, because that's going to be slightly easier, because I can see that that only goes into one bracket. I know it's only one bracket because they've got things in common, they have 2 in common, and they have x in common. And then inside the bracket is going to be x minus 3. For the numerator, now I know that with these questions it would be very boring if nothing cancelled. So I know that it's probably going to be 3x and x here to make the 3x squared. And then because this bracket is x minus 3, I'm pretty sure this one's also going to be x minus 3, because otherwise nothing's going to cancel and it would be pretty boring. So that's what I think. However, let's have a look. We've got 3 here on the end, which means it's going to need to factorise 1 times 3. These numbers here are going to be 1 and 3. If I'd put the 3 here and the 1 here, I get 3x and 3x. And that's never going to make minus 8, no matter where I put the positives and the negatives. So let's try it the other way round. As suspected, the 3 here and the 1 here. And that's going to give 9x and 1x, which could make minus 8 if we make the 9 the negative, so minus 9x, add 1x. And if we multiply that out, it does indeed give that. So we factorise that, and now we've got a common factor. So I'm going to divide the top of the fraction by x minus 3 and divide the bottom of the fraction by x minus 3. And that leaves us with 3x add 1 over 2x. There's nothing else in common to all 3 terms, this term, and this term. So we can't factorise it any further. We can't divide it any further, can't simplify it down any further. That is it. That is an equivalent fraction in its simplest form. For the next question, we've got more algebraic fractions, but this one then becomes an equation, and we're asked to give our answer in the form a plus or minus b root 2, where a and b are fractions. So 1 over x minus 1 over x add 1 equals 4. Now when we are solving algebraic fractions, we need to think exactly the same as we did when they were numbers, and we need to make the denominators the same. The easiest way to make the denominator the same is to multiply them together. So this multiplied by this would give me a common denominator. If I've multiplied the x by x add 1, then I also need to multiply this 1 by x add 1. and then subtract this x multiplied by this one. So you get that, someone called it an upside down picnic bench, which I quite liked. So we're multiplying like that. That is subtracting. You do this times this times this, and this times this, and that gives you an equivalent fraction, but then as one fraction, and that equals 4. Now we can sort that out by making it, because it's x add 1 take away x, that's just 1 on the numerator, over x add 1, but actually I'm going to multiply this side by x add 1 to get rid of the fraction. As long as I multiply this side by x add 1 as well, then that's okay. So we've got 1 equals 4x add 1, and that is 1 equals 4x squared add 4x. Now this is a quadratic. We can only solve a quadratic if it equals 0, so I'm going to take that 1 away from both sides. So 0 equals 4x squared add 4x minus 1. Now, we could see if that factorised, but there was a big clue in the question in that it said we needed to give our answer in this format. And this is screaming out for me to do the quadratic formula. So here I'm going to do the quadratic formula. So that is minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is the number in front of x squared, b is the number in front of x, and c is the constant term here. So we've got our a, we've got our b, and we've got our c. And don't forget if there are negatives to include those as well. So then we're going to do minus 4 plus or minus the square root of 4 squared, which is 16, minus 4 times a times c, all over 2a. And that's going to be minus 4 plus or minus the square root. Now, 4 times minus 1 is minus 16. So here we've got 16 minus minus 16, which makes 32 over 8. Now, a little bit earlier, we saw that if you had a surd, a square root, that had a factor that was 1, 4, 9, 16, 25, or all of the other square numbers, then you could simplify it. And this root 32 has a factor of 4. So we're going to change it. Oh no, it has a factor of 16. That's even bigger, isn't it? It's even better. So we're going to change it to be minus 4 plus or minus root 16 root 2 over 8, which is minus 4 plus or minus 4 root 2 over 8. So that's where we're at. And now, because everything is in the 4 times table, I'm going to divide by that. And my final answer, although I've not given myself very much room for it, is going to be minus 1 plus or minus root 2 over 2. Now, the format of the question said we needed to leave it in this format where a and b are fractions. So I am going to slightly change that answer. I don't want it all over 2. I want to split it. And I'm going to make it minus 1 over 2 plus or minus root 2 over 2, or half. Let's put it out the front because that's what they said to do it. So minus a half plus or minus a half root 2. And now it's in the format that they asked me to do it, and that would get us 5 marks. A very, very challenging question for the higher paper. Hopefully that made some sense. Let's have a look now at proportion. Y is inversely proportional to d squared. When d is 10, y is 4. D is directly proportional to x squared. When x is 2, d is 24. Find a formula for y in terms of x. So I'm going to split this page slightly. Y is inversely proportional to d squared. So when it's inversely proportional, we do it as a fraction. We can't solve equations with fish in them, so we change it to an equals and a k, and that goes like that. And then we're going to sub in what we know. So we know that when d is 10, y is 4. So 4 equals k over 10 squared, which means that 4 equals k over 100. Multiplying both sides by 100 means that 400 equals k. So I now know that the equation is y equals 400 over d squared. I found out what k is. I'm going back to the equation to pop it in. Now let's do the other one. D is directly proportional to x squared. So when it's directly proportional, we don't need to do the fraction. These numbers are going up together or going down together. So then we can't solve equations with fish in them. D equals k x squared. So 24 equals k times 2 squared. I'm just using the values that they've given me. They've told me this is true, and that's going to allow me to get a connection and work out what k is. So 24 equals k times 4. And dividing both sides by 4, 6 equals k. So going back to the second thing you wrote, we now know that d equals 6x squared. I'm going to put a box around that as well. They then want me to find a formula for y in terms of x. Now I've got y in terms of d here, and I've got d in terms of x here. So I'm going to need to combine these. And I'm going to write y equals 400 over, now instead of putting d squared, I'm going to put this squared, because that is d. So 6x squared squared. So 400 over 36x to the power of 4. Squaring 6x squared means squaring all of it. And that's that. We need to give our answer in its simplest form. So these are both in the 4 times table. So 100 over 9x to the power of 4. And I don't think we've got anything else in common there. So that would be my final answer for 5 marks. I did pick some tricky ones for this pack, didn't I? Okay, question 13. P is inversely proportional to T. Complete the table of values. So if P is inversely proportional to T, that means it's 1 over T. Can't solve equations with fish in them. So P equals K over T. We change that fish to be an equals and a K. It's not actually a fish, but it's a bit more memorable like that. Here we've got a pair, so that's going to be a helpful one to use. So I'm going to change the P to be 1 and the T to be 100. Multiplying both sides by 100, we can see that K needs to equal 100. So I can now say that P equals 100 over T. And now we can complete the table of values. To get P, we just need to do 100 divided by T. 100 divided by 25 is 4. 100 divided by, 5 is 100 divided by what? That's 20. And P is 100 divided by 2, so that's 50. There we go. And because they're inversely proportional, you can see that as one got bigger, the other one got smaller. That's how inverse proportion works. And that's it. Those are the 5 topics that I think are really likely to come up. If you've got any questions or any other topics you'd like me to film, let me know and I'll have a go. Let me know in the comments. Thank you so much and I will see you soon.